So today we want to break down some basics about magnetism, and you should just go ahead and follow in your physics notebook. So the first thing is, where do you get magnets from? Just like electricity, you don't have to buy it. Magnetism is one of the 4 fundamental forces of nature, and in fact, electricity and magnetism, they go hand in hand. So you don't have to buy electricity from Walmart, buy batteries, right, or ComEd. It's part of the atom itself. Nature is electrical. You're glued together. Your atoms are stuck together with electrical forces. If you didn't have an electrical force, you'd fall apart. Well, same thing with magnetism. So the source of all magnetism is an electric current. So when I hold this magnet, the only reason why there's a magnetic field is there's electrical currents. But I'm not getting shocked because, again, most items are electrically neutral. There's as many positive as there are negative charges, right? But there are currents that flow. You just don't normally notice them. And normally you don't notice magnetism because most materials are not magnetic. They're non-magnetic. Very few materials are what we call ferromagnetic. So how do we picture this? An electron is the world's smallest magnet. As the electron moves, it'll generate a magnetic field. But the trick is it has to move. So an electron, as it orbits the nucleus of an atom, it has a magnetic field. But as it just spins, electrons also spin like a baseball when you pitch it, and it's got a big spin on it, like a curveball there, right? As it spins, it generates a little mini magnetic field. And usually, if you remember from chemistry, electrons are paired in orbitals where the spins cancel out, so you don't notice that. And every once in a while, you can align those spins if they're on their own, if you have an unpaired electron, and then you get a magnetic effect. So magnetic domains we define as atomic regions where you can line up all those magnets. So if you think about it, here I have 2 bar magnets, and normally they all kind of cancel out, north-south, right? But every once in a while, if you can line up those magnetic fields, bam, bam, then you get an alignment, and you have a net magnetic field that you can detect there. So normally, you have what's called a random alignment. So kind of like when the bell rings and everyone runs out of class, and you take off in the hallway, or actually when you get out of school, that's a better example. Everyone just goes every which way, totally random. Right now, when the bell rings and you're sitting in class and you're all facing one direction, that's what we call a ferromagnetic alignment. And notice in the word ferromagnetic is the Latin root ferrous, which is what we use for iron. It's the atomic symbol for iron, and it's Latin for iron. So ferromagnetic, all it means is you can line up those domains. And iron was one of the first materials we could magnetize there. And all you got to do is, you guys remember how you make a piece of iron magnetic? You can, okay, yeah, if you heat it up, so that the molecules can move around, and then you hit it in one direction, or you rub it against a stronger magnet, and you put in a stronger magnetic field. The domains start to line up. Conversely, how do you destroy a magnet? You can, like, bang it on the table or heat it up, right? But don't do that, because then you'll ruin the magnets. So if you have a nice pair of speakers at home for a home theater system, or headphones, if you bang them around, eventually you'll mess up the magnets in there. So try not to do that. Oh, and keep this away from your electronics like your watch, your cell phone, credit cards, etc. there. So really quick here, I have a giant magnet here. I think this is from a truck engine, so be very careful. Keep this away from your cell phone, credit cards, all that, and then a honking huge nail. Now the first thing I'm going to do is I'm going to mess up the magnetism of this nail by whacking it on the table. There we go. So now what happens to the domains? They're all what? They're all randomly aligned, like this one here. So if you look here, I got a couple paper clips here, and I got to keep this magnet away from the computer. There we go. And if you look here, I'm not going to be able to really, oh, it's still got a little magnetism left, but I can pick up maybe 2 paper clips. That's about it. So if I want to make this sucker magnetic, I'm going to take this thing to a stronger magnetic field. So I could either heat this up and then pound it, or put it in another magnetic field, in this case from the truck magnet. And then all I'm going to do is I'm going to stroke this all in one direction. So what's going to happen to those magnetic domains? If there's little tiny compasses in there, think of it that way, they'll all start to do what? All start to line up. You see that? For a while, there was a big fad where some golfers, they still do that. They wear like magnetic bracelets. I'm talking about ankle clasps, like belts, beds, shoes. Actually, I was going to buy my mom like this magnetic mattress because she's got like a bad back kind of thing. But then I asked the person in the store, how are the magnets sewn into the mattress there, yeah? And they're like, oh, I don't know, probably doesn't matter. And I was like, yeah, there we go. It's a scam, right? Because if you sew in the magnets randomly, what happens to their magnetic fields? They'll all what? Cancel out, right? If they're in the same direction, then you have the magnetic fields line up. And I think the theory with that is if you have a magnet bracelet or necklace or whatever, what can it attract in your blood? Anyone know? Yeah, you have a little bit of iron in your blood for your red blood cells. So then it should get more oxygen-rich blood to your wrist or whatever, yeah? But mostly it's junk science. But if it helps you, it's psychological, go for it. Or just duct tape some magnets to your head, you'll do better on your tests, right? Or not get lost. So anyhow, now that I lined up the domains here and all goes well, we should see that instead of just like 2 paper clips, I should be able to pick up maybe a few more because the domains are all lined up there. And it looks like I'm still only getting, oh there, I had 2, maybe 2.5 there. But that's, oh, there we go, 3 paper clips there. So that's how you magnetize a piece of metal there. Why would you magnetize in real life like a screwdriver or a drill bit? Anyone know why? Because then you could hold it in place, exactly, right?